indication of a tropical lagoon habitat, and the lagoon is oftentimes characterized by being relatively shallow, maybe less than 30 feet deep, and somewhat protected. So here at Academy, we've interpreted with a coral reef offshore, kind of creates the wave action out on the ocean side, but then on the shore side, we have a mangrove intertidal zone. So we have mangrove trees behind the rock, and oftentimes that would be a mangrove intertidal zone or a beach. So this shallow protected area is an excellent nursery for a lot of the different fish species that we have here on exhibit today.
That's right. Now, what's really interesting is that when we glance at this exhibit, you might notice a few different types of animals in here, but these are all actually types of fish. They can be characterized, grouped into two different groups, the teleosts and the elasmobranchs. Can you explain to us what exactly the difference is between those two groups?
Definitely. So for our teleosts, or also known as bony fish, these are fish that have a hard calcareous skeleton. And our teleosts in our lagoons here are a lot of our schooling silvery fish in the center. So you'll see they have kind of yellowish fins, silvery bodies. These fish have that hard calcareous skeleton. Now that is actually in contrast to our elasmobranchs. And in our exhibit here, our elasmobranchs are our sharks and our rays. So these animals are characterized by having a skeleton made predominantly of cartilage. So if you touch your nose, or if you touch your ears, you're touching your bone cartilage that you have in your body, and our sharks and rays in this exhibit have skeletons made predominantly of that material.
Now, Tim, what exactly are the advantages of having a skeleton made out of cartilage?
Well, there's actually a lot of different advantages. One advantage is it's lightweight, flexible, and kind of bounces back in shape. If you've ever walked into a glass door, usually your nose kind of bounces right back. If someone pulls your ear bounces right back. A lot of these animals have a lot of cartilage centralized in their heads. If they bump into something, it'll bounce right back. So it's very flexible. It makes them very agile and efficient swimmers in the water.
Excellent. Now today we're actually going to be feeding some of those elasmobranchs, those rays with the cartilaginous skeleton. Can you maybe introduce us to some of the different ray species that we have in here?
Yes. So for today's feeding, we're actually doing a training feeding session, really cool, and we're going to be hand feeding our Javanese palinode stingrays. So if you look along the perimeter of our exhibit, we have a school of these guys right here. They're more of a pelagic ray. They spend more time up swimming in the water column than they do come down to feed. So we're feeding those guys today. Some of our other rays on exhibit, we have our large female honeycomb stingray, that large spotted ray on the bottom of the exhibit. The other common name is whiptail ray for that animal because that really long tail. Finally, we have two smaller ray species. We have this little brown guy in the middle, that's a blue spot stingray. And over here we have a blue spot ribbon stingray with really nice electric blue spots. And we also have a zebra shark in this exhibit, and you kind of see him cruising along. It's actually coming along the exhibit right at the crest of the boardwalk.
Excellent. Now, Tim, all of the rays in this exhibit are true stingrays, and that they have a stain bar at the base of their tails. So I have to ask, are you a little nervous to get in the water with them today?
Actually, not. We get this in this exhibit all the time, and part of our training is to help build a relationship with these animals and get them familiar with our presence. And so, actually, not.
All right, awesome. But that being said, is it true that all stingrays have a bar, or that all rays rather?
That's a really good question, but actually not all rays have a venomous bar. And plus, I can give an example here of a manta ray. And manta ray is an example of a ray that does not have a venomous bar.
So these manta rays, as you can see, they're quite large. We've got a picture of the diagram down here at the bottom. Has anyone ever had the opportunity to see a manta ray in the wild? Excellent, a couple of you. Well, I really like to think of these rays as gentle giants. Again, they lack that bar, and they actually are filter feeders. They feed on plankton, like you might think of baleen whales is doing. But these rays in particular, they're facing some challenges out in the wild currently. What are some of the reasons manta rays are struggling out in the ocean?
Well, some of the challenges that manta rays face out in the wild is that they're actually being harvested out of the oceans faster than they can be produced. And oftentimes they're being harvested for food or traditional medicine.
Right. Now, there are some great ways that we can help these rays. One great way is to go visit them out in the wild. To mention that they're sometimes harvested for food or medicinal uses, but they're actually much more valuable alive in the tourism industry. So, Tim, where might we go if we wanted to see some manta rays out in the wild?
Well, manta rays occur in a lot of tropical pelagic regions of the world. One of the great places in the U.S. that you can see them is actually off of the Kona coast of the Big Island of Hawaii.
All right, awesome. I would like to go to Hawaii if you're helping Show hands. All right, I thought you might. So here I have some seafood watch cards that you can grab from me after the program, and they help you to kind of determine what are some good choices to make when you're purchasing seafood out of a restaurant or out of the store. So Tim, what exactly does it mean for seafood to be sustainably caught?
So for sustainable seafood, it means that the method of capture, the populations, and species are all taken into account about whether or not it's sustainable to harvest for food.
Alright, now speaking of sustainable seafood, we actually feed our animals right here at the Academy Sustainable Seafood, correct?
We do, and so for today's feeding and training session today, we're feeding prawns and squid predominantly to our rays.
Delicious. That makes me really hungry after a little seafood lunch. Alright, well Tim, I can see there's a lot of action in here. It looks like the rays know it's about time for the feeding. So I understand you're going to go ahead and hop in the water?
Yeah,
Alright, excellent. So this is a great time to just kind of watch the behavior in this exhibit. You'll quickly notice that these rays are certainly alert to our biologists getting ready to enter the water, and you know that it is time for feeding. Now, as Tim mentioned earlier, this is a really special kind of feeding. Not only are these rays getting their food for the day, but this is also what we would call a type of enrichment for our animals. So enrichment basically means anything that is helping us to bring out natural behaviors for these animals here in the academy, helping us to enhance their quality of life here and provide them with a little extra stimulation. So you can see as Pam begins target feeding our honeycomb ray, our Hydrotura, you may have noticed her kind of clicking the end of those tongs there to call the ray over. Now, you can see Tim doesn't have any special tools necessarily over there to call the rays over, but you might notice that the rays have an interesting signal to help them know it's feeding time, and that is simply by seeing Tim enter the water. So Tim, it looks like they all caught onto it really quickly. How's the feeding going so far?
It's going really well, and you're right. So once they get in the water, they recognize me and having these food buckets as kind of like a target and location of where they need to come to get their food. And by hand feeding them, this kind of training and enrichment, we're able to evaluate how much the animals are eating and make sure they all get enough.
Excellent. So doing these, what we would call a target feeding, really helps us to look at the quantity of food that each of these individuals is eating. And that's really important in helping our biologists really evaluate the health of these animals. So Tim, what might increase or decrease in appetite tell you about the rays?
Well, so as you mentioned, these animals, they can't really tell us if they're not feeling well. So oftentimes we use their appetite or the amount of food that they're consuming to determine if they're not getting something off or something wrong. So by being able to tell how much these animals are eating, we can potentially catch something a little bit earlier.
Excellent. And you've probably noticed already these Kauto's rays are really comfortable around Tim. You may even notice Tim touching the dorsal side, the top side of their bodies, kind of getting used to that human touch. And this is really important again in really enhancing, a little action down there. And really enhancing the quality of life for these animals here in the exhibit. As you can imagine, out in the wild, being touched or maybe grabbed by a human is not really something these animals experience often. If one of our biologists or vets does need to look at these rays, having them kind of used to that human touch means that that process is much more stress-free for them. Now, one interesting thing, Tim, that you mentioned earlier is that some of the rays in here are what we would consider to be benthic rays and spend most of their time on the ocean floor, while some of the others tend to spend their time out in the open ocean. So how do the different feeding stations correlate with where these animals spend their time in their lives?
So as I mentioned, our Kauto's rays are more for flash rays. They spend a lot more time out in the open water. They do have to come to the bottom to feed. However, they do actually cope really well with the training that we're doing now. So even though they are off the bottom, they're still swimming directly over my hand to suck up the food because their mouth is located directly below their head.
Right now, you pointed out something interesting there, Tim. Their mouth is pretty much on the opposite side of their eyes. So you can probably imagine using eyesight, not the best means of finding food for these animals out in the wild. So can anyone guess what senses they might use to help them find their food? Sense of smell, perhaps? Any other guesses?
And it's a really cool sense. It allows these animals to detect minute electrical impulses that are generated by other living organisms, including the prey.
Absolutely. So every time that we move our bodies, even if you all just wiggle your fingers right now, you're sending out small electrical signals, and these rays of sharks are actually able to detect those using that sixth sense. Now, oftentimes these rays might feed on mollusks as well, so shell animals. So you might notice that they have some interesting teeth compared to some other animals you might imagine out in the ocean. So here in my hand, I have an example of a bat ray, jaw, which is very similar to that of the cow nose rays that we have here in our exhibit. Tim, how do these plates help these animals eat things like clams or mussels that might find out in the ocean?
So the jaws that you have there are extremely helpful for these rays to eat the types of food that you'd be eating naturally out in the wild. Our rays are